Hi, I'm Darren, and welcome to Level Up EE Lab. In today's episode, I'll be continuing the repairs of this SX140 amateur radio receiver. I'll show the details of the repairs and component replacements that I performed, fire it up and find an embarrassingly simple issue, and show test results that prove the old film and electrolytic capacitors really were in bad shape. This is the first episode I'm recording using my Sony ZV-1 camera. And for comparison, I'm also doing a side-by-side recording of this intro with the Sony CX260. That's the camcorder I've used for all my episodes until now. First impressions, it definitely records at a much higher quality than the older Sony, and that's, I guess, no surprise. It's a much newer camera. But for sure, I'm still figuring out how to use it correctly, so this episode really isn't going to have maybe the optimal settings for my future episodes. Anyway, on to the Hallicrafters SX140. I've completed the cleaning work on the front panel and controls, and it does look very good. It didn't need that much work, and for sure, I was gentle on my cleaning techniques. The graphics are still very sharp, and the dial in particular still looks almost new. Now, because I removed the front panel from the chassis, I had to remove and then restring the dial cord, and boy, was that a pain in the neck. These cords are rarely easy to install, and getting a technique that worked took me almost 2 hours. The method shown in the manual just plain doesn't work, so I had to improvise, but in the end I finally figured it out. And one more item before I get into the details of the chassis repairs. Many of the components that I replaced were just tack soldered in place, like this 820 ohm resistor. Clearly these were replacements, and the prior tech didn't bother to properly solder them in. I made it a point to not use the same poor workmanship with the work that I did, although there was one connection that I had no choice but to do a flying lead solder joint just because the distance was too long for the resistor to span, but I made it a secure joint and put heat shrink tubing over it to make it more protected. So with that all aside, let's take a closer look now at the repairs I did make on the chassis. Alright, several hours of work later, I'm done with all of the repairs and maintenance that I wanted to do to the chassis of the SX140, and I've got it set up here in my turntable, and I'll walk through the highlights of the things I had to address, and I'll also include some zoomed in video of some of the areas of particular interest. But right from the top, I mentioned in the prior video that I wanted to replace all of the electrolytic and film capacitors, so those have all been changed out now. And wherever possible, I was able to match the value, but I went higher in rated voltage. A lot of those older electrolytics kind of pushed the limits of their voltage, so I tried to go just a bit higher wherever I could. Another thing to notice is on the foil caps, I use a technique that Paul at Mr. Carlson's lab recommends, and that is to identify the foil end and put that in towards the low impedance of the ground side of the circuit. So you'll see in all the yellow caps here, I've done that. I have a simple technique to be able to do that and make sure to put them in circuit correctly that way. I also, over on the power supply side, I basically completely rebuilt this section right here. Not only the capacitors for the filtering, but also put in 2 new safety caps on the AC side, and I replaced those 2 resistors that were out of spec. In fact, this 100 ohm resistor, if you recall in the prior video, was burned out, so definitely had to replace that one. Let's see, other things that I did replace the line cord. I put in a brand new one here, just a regular old extension cord that will work just fine. Now, I did want to try to include a fuse, but there just isn't any space in this area here. I probably could have put in a leaded fuse and soldered it into the terminal strip, but didn't have one available, so just decided to forego that for now. And the potentiometers, these are the audio gain and selectivity potentiometers, and those were bad. I think I mentioned that in my prior video too, so those are replaced. Now, one little minor setback there. When I ordered those, I knew they were going to be smaller, but I thought they'd be the same body diameter for fitting into the hole in the panel. Unfortunately, they're not. They're smaller diameter bushings, and could have replaced them with new ones, but Being the intrepid mechanical engineer that I am, I decided I would design and 3D print some adapters. So that's what I did here. These adapters let the smaller diameter bushing fit into that larger hole, and it preserves the keying to prevent them from rotating. So that turned out nice, and I've got those two adapters installed there, and the pots are nice and secure. One more highlight to talk about during the cleaning was the switch contacts. So there's several multi-gang switches, very common with the receivers of this era. And to clean those, what I use is a technique that I really like. I use the eraser end of just a regular old pencil, and where I have access to get in there and just very gently rub off that oxidation, and it works quite well. And not every contact point can be reached, so I'll just use conventional solvent-based evaporating contact cleaner and use that where the contacts are a little tarnished and clean those up. So other than that, the radio is now ready for the first power on test, and that'll be next. Okay, it's time for the tubes out power on test, as I like to call it. I've got the SX140 set up here. I don't have any of the vacuum tubes in yet. I'm just checking out the power supply circuit. So in order to do that safely, I'm using this gizmo here. This is my dim bulb tester that I featured in one of my earlier videos. If you haven't seen that, essentially what it is, it's a variac with an isolation transformer and an incandescent light bulb here, and then an AC voltmeter that I made to be able to vary the amount of AC volts that I apply through the line cord into the device under test. And this way I'm limiting the current here with this light bulb, which you can't really see, but it's back there kind of tucked behind the panel. But if that starts to glow while I do this test, then that's a good indicator that there's a problem. Another piece of equipment that I got set up is just a multimeter over here. This is measuring the main DC circuit in the radio, and that should be about 225 volts when I've got the full AC voltage applied. So just to run this test, what I'll do is I have everything shut off. So to start it,
this item contains hazardous voltage and safety precautions must be followed. If you're following along and working on your own version, you're doing so at your own risk.
I'll turn the radio on to standby, and the variac is dialed down to 0, so I'll turn on the unit, and it starts out with just a few volts since I can't get it quite to 0. But already you can see there's a couple hundred millivolts showing up in the power supply over here. Now, as I gradually increase the AC voltage, and I'll do it this way so we can watch the meter change, we're looking for any glow of this light bulb. If that starts to glow brightly, then it indicates there's a problem. But we can also watch the DC output meter on the right as I increase the applied AC volts, and you can see I'm already almost at 100 volts DC coming out with 50 volts AC going in. So I'll keep cranking this up. I'm not seeing any glow in the dim bulb, so that's a good sign. In fact, I think I see the panel bulb starting to light up on the back side of the radio. It may not be coming through on the camera, but that's a good sign that the 6 volt side of the 6 volt AC side of the transformer is working fine. Okay, so I'm almost at 100 volts now, and I've got almost 200 volts out. So I'm soon going to reach the limit of my variac here. I can't quite get to full AC voltage because there's a little bit of drop in that bulb. It is glowing very, very dimly. I don't think it's going to come through on the camera, but that's fine. There's always a little bit of voltage drop across there, but you can see I'm up at 215 volts DC, so that's good. I don't see any of the magic smoke coming out of the SX140, so that's another good sign that things seem to be working okay. So next test, what I will do is put all the tubes in, and then I will still power it up with my dim bulb tester, but I'll hook up a speaker and an antenna and see if we can get any signals. Before I reinstalled the tubes, I gave them a light cleaning. If you recall, the chassis was covered with that fur-like dust and gunk accumulation, and so were the vacuum tubes, especially the tops. Here's a cleaned one. Now be aware, you cannot just spray them and wipe them off. If you do, you'll end up removing some or all of the printing on them. So I use a cotton swab and some soapy water and clean carefully around the writing. It's not a perfect technique, but they do end up a lot cleaner, and judging by the dirty swabs, I did get a lot of the gunk off. And also I do want to comment about reinstalling the tubes. Notice that I use an old egg carton to keep them in correct order. They aren't all the same. Installation is not that hard, but you do need to be gentle. You're pushing on a glass object with bendable metal pins into a socket that is much more rigid than the tube. They only go in one correct way, so align them by sight first, then by feel second, and then wiggle them home until they are seated. Okay, I've reset up the SX140. I've installed all the vacuum tubes, all 5 of them. I've also got a speaker temporarily connected, and I've got my 40 meter antenna connected with just some jumper wires as well. Still using the dim bulb tester. I want to keep that in circuit for all these tests. So here we go. We're going to power this on and hopefully hear some sounds out of the speaker. Now, this is late November here in my workshop. The furnace keeps coming on every now and then, so the ductwork will be clicking and popping and thermally expanding, contracting in the background, but we'll work around it. Hopefully we'll hear more than that. I'll actually hear some audio coming out of the speaker. So here we go. And I will turn the radio all the way to CW SSB mode and start cranking up the voltage. And you can see that bulb is glowing more now, which is expected because the power supply is drawing more current. The filaments on the bulbs are coming up. I can see them over the top of the chassis, although we can't see them on the camera, but they are. And you can also see I can't reach the full voltage on the variac. The incandescent bulb is causing more of a voltage drop now, so I'm going to have to switch it out of the circuit. And I'll do that by backing off on the variac a little bit, flipping this switch, and now the voltage jumped up, and we'll do a full 115 volts. Should be fine. Let's see if we have anything. I definitely hear a little hum, but I don't hear any RF static. So the RF gain is down. Let me try cranking it up to about mid travel. I do have it set on 40 meter mode. Still not hearing anything, and the S meter is pegged, which is also interesting. Let me try some BFO injection. Put that about halfway. Still hear some hum, but no signals. Not even static. Well, the hum is telling me that the audio circuit is probably working fine. All right, let me try another band. Put that on 80. Every time I turn it, I hear a click from the speaker. There's 20 meters. Nothing. Well, I don't think the antenna trim nor the cal reset. The cal reset is actually a capacitor that's in parallel with the capacitor that does the main tuning, so that's not having any effect either. Well, folks, this is a little unexpected, so I think I'm going to have to set this on its side and think about how I'm going to troubleshoot the circuit and see what's going on. First, I'll check to make sure all the tubes are actually lighting up, and then if they are, then I'll have to start looking at the audio section appears to be humming. So I'll work backwards from the audio section and see if I can find out what's going on. All right, I am back from probably one of the shortest troubleshootings I've ever done on a radio. As it turns out, it was just the vacuum tubes were loose in the sockets and they weren't all making good continuity. Now, when I did the cleaning, I cleaned the wafer switches, but I did not clean the vacuum tube sockets. So I used a little bit of deoxit in there, and lo and behold, the radio comes to life now. So it's like chromatic. I was hoping to show it come to life for the first time on camera, but nonetheless, it's working. So just for a quick test here, I put it on 40 meters and the dial calibration is off. So I just manually set it just roughly for the FT8 crowd. That's at 7.074 megahertz. So they're pretty much going to be on day or night 24/7. And there they are. For those of us who communicated an FT8, we're very familiar with that audio signal. So that shows 40 meters is working quite strongly, actually. Now, there's a kind of a funky interaction on this radio between the RF gain setting, the selectivity or the BFO oscillator, and audio. You kind of have to fiddle with all three as you're trying to tune in a CW signal or a single sideband. So what I'm going to try to do is just manually tune down the band here, see if I can work my way through these and get some CW to come through, some Morse code. And there we go. So certainly faster than I can copy, but the CW is coming through nicely. Now, another thing I noticed in the manual is this meter, notice it's not labeled a S meter, it's a carrier level, and as it turns out, it's not an S meter in the traditional sense that we think of. It only functions when you're listening to an AM station, and then in that case it will give you a relative reading of the strength of the carrier. So it doesn't work for right now for CW or SSB. So what I'll do next, I'll tune up the dial and try to dial in some SSB signals next. Okay, I've tuned up dial and I'm in a range where I thought I heard some activity. Let's see if they're still there. Definitely touchy, because if I tune the BFO out of oscillation, then the signal drops entirely. There we go. And if you don't have it with this type of tuning for single sideband, if you don't have it right on the right frequency, you're going to get that Donald Duck or garbled sound to it. So that's why it doesn't sound very good. And clearly I haven't used this radio enough to really know how to use it well. So I'll maybe try again here. There we go. That's intelligible now at least. So it is working, and what I'll be doing next is the alignment and calibration from the manual. Part of the alignment procedure is making sure that the crystal calibrator is working correctly, but I overlooked the fact that I don't have the 3.5 megahertz crystal that it needs. Now I rummaged through my junk box and I did find a color burst crystal. It's 3.57954 megahertz, and that's close enough in frequency, but it's not the right form factor, so it's just not going to plug in the way it is. So I'm going to have to make an adapter to plug it in. So that means I'm going to have to defer the alignment to a third episode in this series, but that's actually pretty good because I didn't want to rush the alignment and end up making a mistake by overlooking something important. So making a third episode kind of makes sense. Plus I still have to make a decision on painting the case as well as the case on the HT40. Both of those do need to be repainted. But before closing this episode, I thought I'd share something interesting about those 10 capacitors that I replaced. If you recall from the last episode I did on this project, I mentioned that I just take a shotgun approach and replace them all. On any equipment this old, I just don't trust the capacitors to be good, and it's based upon my personal experience and basic engineering judgment. But are the capacitors really bad? Well, I can actually answer that with data. What I've got is a capacitor leakage tester. In fact, it's yet another piece of gear I've built for my lab, and the design comes from Paul over at Mr. Carlson's lab. Now, my version is pretty ugly. I built it from almost all junk box parts, including using a large chunk of perf board mixed with jumper wires instead of making a custom circuit board. But it does work very well, and I've used it many times to characterize new capacitors and old capacitors, and I have comparison data to reliably judge between them. As a demonstration, here's me testing a new 10 microfarad electrolytic. It's able to reach a green light status in about 5 seconds. Now, here's one of the 10 microfarad caps that are removed from the SX140. Even though it's not visibly leaking electrolyte, it tests very badly. Even after 2 minutes on the tester, not only doesn't it reach a green light status, but the 10-segment bar graph doesn't even budge. It definitely has an unacceptably high parallel resistance. And here's how all 10 of the replaced capacitors tested. This column shows the typical performance for new capacitors of the same capacitance. And this column shows how each of the 10 removed capacitors actually measured. Note that in all but 2 cases, I stopped the test after 2 minutes because the charge current wasn't decaying at all, not even a single bar graph segment, so those caps are definitely garbage. 2 of them did test a bit better and did reach green light status, although at recorded times substantially higher than a new equivalent. But they're still so far off that I would not even consider using them. It's just not worth risking damaging a rare vacuum tube, say, from excessive grid current. It's not worth the couple of bucks you save by not replacing that suspect capacitor. So that's all I have for today's episode. I hope you enjoyed it. Please click that subscribe button if you haven't yet, if you're enjoying these videos, so you get the usual automatic updates as soon as I publish something. So until next time, bye for now.